Hey guys, my name is Aaron, and today I'm going to show you guys a really cool science experiment. The experiment has to do with the capillary effect. The capillary effect is the movement of a liquid along the surface of a solid caused by the attraction of molecules of the liquid to the molecules of the solid. This movement can even defy gravity. So let's see this process in action. So in order to be able to do this experiment with the capillary effect, you're going to need a napkin. And with this napkin, you're going to need to fold it like so. About 4 or 5 folds in until you get it like this. Then, after, you're going to need to divide it into 2 and press hard. So that you kind of have like an arrow shape with your napkin. Next, you're going to need 2 glasses, one without water and one with water. And what you're going to do, put the glasses next to each other, and slowly dip the napkin, one side of the napkin into the water, one side of the napkin into the empty glass. So you have it like this. If you look closely, you can slowly see the transfer of water from the glass with all the water to the glass with no water through the napkin. This is due to the capillary effect. The capillary effect is filling the glass that originally didn't have water with water. Fast forward a couple hours and we can see that there is now a good amount of water in the glass that originally had no water in it, coming from the glass that had all the water. The amount of water isn't as much as its counterpart, but it's getting there. It's a gradual process, but if you look, you can see the movement of water from one glass to the other. A couple more hours go by, and we end up seeing this. The amount of water in the glass that originally had no water has increased. Meanwhile, the amount of water inside the glass that had all the water has decreased. The transfer of water is going nicely. Quite a few more hours go by, and we see that the amount of water in both glasses has equaled out. Due to the fact that the glasses are now in equilibrium, the transfer of water will stop here and the capillary effect will effectively have done its job. Now let's take a closer look. Due to the sticky properties of water, water molecules are attracted to other water molecules and other substances. Adhesion is water's tendency of being attracted to other objects, forming hydrogen bonds between them. Meanwhile, cohesion is water's tendency to be attracted to other water molecules, forming hydrogen bonds between them. So sort of like adhesion, but adhesion forms bonds with other objects, while cohesion just forms bonds between the water molecules. The water molecules' attraction to each other causes surface tension. This is what causes water's sticky tendencies and the wet feeling you get when your finger or body makes contact with water. Water's adhesive nature to the paper napkin, as well as its cohesive nature for the water molecules to stick together, allow the water to defy gravity. This is what we see when colored water goes up the napkin into the other glass. The paper towel industry owes its existence to the capillary action, both for the way paper towels soak up liquids and for the trees of which the towels are made. When liquid spills and you use a paper napkin to clean it up, you put the paper towel onto your mess, the liquid adheres itself to the paper fibers, and the liquid moves to the spaces between and inside of those fibers, using the capillary effect. However, this isn't the only use of the capillary effect. It is also seen in nature. When plants put their roots in the soil, they absorb water from the soil to the plant. Therefore, when water gets inside the roots, they start going up the plant tissue. Water molecules attach to each other and to the tissue of the plant, going up the plant. But you are affected by the capillary effect every day in school and don't even know it because the capillary action is needed to keep the ink flowing on the paper when you're using a fountain pen. Well, that just about wraps up the capillary effect. I hope that you guys all enjoyed my video. I just want to give a quick shout out to eSTEM for all the great work that they do. Until next time, goodbye guys.